Lesson Whole Numbers Part 3 Properties of Whole Numbers. Studying the properties of whole numbers help us to understand numbers better. Let us look at some of the properties. The properties of whole numbers include closure for addition and multiplication, commutative property for addition and multiplication, associative property for addition and multiplication, distributive property of multiplication over addition, identity for addition and multiplication. We shall understand these properties one by one with some examples. Closure property. Consider any two whole numbers, for example, 11 and 21. When we add these two numbers, we get 32, which is also a whole number. Some more examples. 1 plus 9 is equal to 10, a whole number. 13 plus 2 is 15, a whole number. 56 plus 22 is equal to 78, whole number. 101 plus 201 is equal to 302, a whole number again. In all the above examples, we can very clearly see that when we add two whole numbers, the answers are also whole numbers. Can you identify any pair of whole numbers when added will not give a whole number? Well, we see that no such pair exists. This property is known as closure property of addition for whole numbers. Closure property states that addition of two or more whole numbers gives another whole number. If x and y are two whole numbers, then x plus y is also a whole number. Then a collection of whole numbers are said to be closed under addition. Let us check whether the collection of whole numbers is closed for multiplication too. Observe these examples. 5 into 6, 30, a whole number. 10 into 10, 100, a whole number. 17 into 12, 204, a whole number. The product of any two whole numbers is found to be a whole number too. Hence, we say that the collection of whole numbers is closed under multiplication. We can now conclude that whole numbers are closed under addition and multiplication. For example, 3 plus 5 is equal to 8, a whole number. 3 into 5 is equal to 15, a whole number. You should now be thinking, what about other two operations, subtraction and division? Well, let's find out. Consider the examples 5 minus 3. Yes, we get a whole number. 10 minus 5, a whole number. But if we interchange the digits, that is 5 minus 7, this is not a whole number. 5 minus 10 is not a whole number again. You can see that closure property doesn't work when the minuend and the subtrahend are interchanged. It works only when minuend is bigger than the subtrahend. Hence, whole numbers are not closed for subtraction. Closure property for division. Consider the examples. 10 divided by 2 gives us 5, a whole number. 6 divided by 6 gives 1, a whole number. 18 by 3 gives 6, a whole number again. But 11 by 2 gives 5.5, not a whole number. 6 by 5 gives 1.2, not a whole number. 10 divided by 7, 1.42 is not a whole number again. In the above examples, we observe that closure property works as long as the divisor is a factor of the number under consideration, but it does not work for any other combination. As decimals and fractions are not whole numbers, we can say that closure property does not hold good for division too. We can finally conclude that whole numbers are not closed under subtraction and division. Division with 0. 0 divided by a number equals 0. For example, 0 by 5 gives us 0. Let us consider the other way. 5 divided by 0. Here we have to subtract 0 again and again from 5. 5 minus 0 is 5. 5 minus 0 is again 5. 5 minus 0 is again 5. And so on. So when will this stop? So 5 divided by 0 is not a number that we can reach. The division of a whole number by 0 does not give a known number as the answer. Dividing by 0 is impossible. It is undefined.